Good evening, Titans. This is Mr. Simpson. And tonight we're going to be starting lesson 6.3. Okay, this is from lesson 6.3. The essential question: what are some of the characteristics of a graph of an exponential function? Now, remember we've talked about linear functions, and we have talked about some nonlinear functions, but today we're going to be talking about an exponential function. So, right here, an exponential function is a nonlinear function of the form y equals a times b to the x power, where the a cannot equal 0, b, meaning the number that's raised to the power, cannot equal 1, and b must be greater than 0. And then as the independent variable x changes by a constant amount, the dependent variable y is multiplied by a constant factor, which means consecutive y values form a constant ratio. That's different than a constant difference. A constant ratio is that when we divide the numbers, then it ends up being the exact same number. So in this case, it says, does each table represent a linear or an exponential function? Well, if we notice, these are increasing by 1 each time, so those are increasing by a constant amount. This is increasing by 2. This is increasing by 2. That's increasing by 2. So what we have in A is linear. Now here, again, these are increasing by 1 each time. This is 4, this is 8, this is 16. Well, obviously those aren't the same. So that's not linear. So now we're going to see, does it form a ratio? Meaning if I take the 8 and I divide it by the 4, what do I get? Well, I get 2. If I take the 16 divided by the 8, I get 2. If I take the 32 divided by the 16, I get 2, which means I'm multiplying by 2 each time to get to the next number. And if you're multiplying or dividing to get to the next number, then that represents an exponential function. Excuse me. Here, we're given exponential functions. And again, how do we know they're exponential functions? They're raised to a power of x. So if I have y equals negative 2, and then times 5 raised to the x power, they want me to evaluate this if x equals 3. So I substitute in. So I have negative 2 times 5 to the third power. So by order of operations, I must do 5 to the third power first, which is 125, because 5 times 5 times 5. Then I have to take that times a negative 2. So my answer is y equals a negative 250. Well, now we're going to look at example B. In example B, we want to evaluate y equals 3 times 0.5 to the x if x is a negative 2. Now, so when we do this, we have y equals 3 times 0.5 to the negative second power. Now, 0.5 is the fraction 1/2. And we want to do that because in this case, 1/2 to the negative second, again, we're in negative power, make it a positive exponent by doing the reciprocal. So 2 to the second would be 4, and then I have to take that times 3, and 3 times 4 is 12. So now I've evaluated. So again, when you're asked to evaluate exponential functions, you're replacing the exponent of x. That's what makes it an exponential function, because the exponent is my variable. And then I do the order of operations. So I must do powers first and then do multiplication. So again, here's just a couple more examples of the exact same thing that we are doing. And so if we look at this, these are increasing by 1 each time. I'm going from 8 to 4, 4 to 2, 2 to 1. And it looks like if I divide by 2 each time, I get the same thing. Or if if you think of it as multiplying, you're multiplying by 1/2. Multiply by 1/2. Multiply by 1/2. Okay, so this would be exponential. This one, these are adding 4, adding 4, adding 4, so that's a constant rate. And in this case, we're subtracting 1, we're subtracting 1, we're subtracting 1. Since it's subtraction or addition, then this represents a linear function. Here we're asked to evaluate. So again, we're going to evaluate. So I have 2 times 9, and they want me to do it for x to the negative 2. So 9 to the negative second would be 1 over 9 to the positive second, which would be 1 over 81, times 2 would be 2 over 81. And if I plug 0 in, well, 2 times 9 to the 0 power. Well, anything to the 0 power is equal to 1. So this is 2 times 1 is 2. And then they want me to plug 1/2 in. So I have 2 times 9 to the 1/2 power. Well, 9 to the 1/2, remember, a fractional exponent is the square root. So 9 to the 1/2 is the square root of 9, which is 3, and then 2 times 3 is 6. All right? And we do the same thing for number 4. We'd substitute in a negative 2 for x, then we'd substitute in 0 for x, and we'd substitute in 1/2 for x. And evaluate those and get some values. All right, graphs of these. Well, graphs of exponential functions look like this. If the a is positive, meaning the number that we're multiplying by the b to the x, okay, this number here, if this is positive, my graph looks like this. If it's negative, then it would reflect over the x-axis, just like it did before. Okay? So, now, and that's if b is greater than 1. Now, if b is a fraction, meaning if it's y equals, say, 2 times, and b is 1/2 all the x, then if it's a fraction, then it's a decreasing function like this. We call this one an increasing function, because as we move to the right, it's increasing. And this one we call a decreasing function, because as we move to the right, the line is going downwards. All right, so now we're going to look at, so here it says graph f of x equals 4 times 2 to the x. So we want to complete a table first, plot the points. So if we plug in a negative 2, so I have 4 times 2 to the negative 2. Well, 2 to the negative second is 1 over 2 to the second, which is 1/4, times 4 is 1. Then I have to plug in negative 1. So now I have 4 times 2 to the negative first. Well, 2 to the negative first is 1 over 2 to the first, or 1/2, times 4 would be 2. And then I plug in 0. Well, 4 times 2 to the 0. Well, 2 to the 0 is 1, and 4 times 1 is 4. Now I plug in 1. So now 2 to the first is 2 times 4 is 8. And then I plug 2 into the second. 2 times 2 squared is 4, and 4 times 4 is 16. And now I plot these points. So negative 2, 1. Then I have negative 1, 2. I have 0, 4. I have 1, 8. And I have 2, 16. As you can see, my graph is going to go like this. It increases very rapidly. Very rapidly. All right? And that's the graph of f of x equals 4 times 2 to the x. That would be called an increasing function. And the last graph we're going to do here, so I have 1/2 to the negative second. So again, take the reciprocal of that. That's 2 to the positive second, which is 4. Then the opposite of that is a negative 4. Then I have 1/2 to the negative first. So again, the reciprocal of that changes sign of the exponent. 2 to the first is 2, and the opposite of that's a negative 2. 1/2 to the 0 is 1, and the opposite of that's a negative 1. Then I plug in 1. So 1/2 to the first would be 1/2. The opposite of that would be a negative 1/2. And then I plug in 2. 1/2 squared would be 1/4. The opposite of that would be a negative 1/4. So I have negative 2. Negative 2 did this wrong. Negative 4 took the wrong graph here. Sorry about that, guys. Negative 2, negative 1, negative 2, 0, negative 1, 1, negative 1/2, and then 2. And so in this case, this graph looks like this. Okay. All right. So again, that's graphing rational functions, or excuse me, graphing exponential functions. And we'll take a look at more of these tomorrow in class. If you want to give these two here a shot, that'd be great, but no problem if you do not. Okay. Good night, Titans.